All right. I think we're perfectly 25 minutes late. So that's time to move on to the last invited speaker session of the day. So I should say congratulations, you made it through the 75% or almost 80% of the workshop. And our first invited speaker of the last session is Dr. Ross Knepper from Amazon Robotics AI. So he is our last speaker also from industry today, and we're really looking forward to listen to your talk. And if you come here, I can help you set up the screen. Yeah, thanks. The screen sharing.
Okay, so I got that.
This one goes into the USB, and then when you do screen share here. Oh, choose the presentation.
Let's just do that.
I think this one, right?
Or
No. Is that the one?
I'll just do the whole.
The whole day. Okay, cool. Yeah. So here you do optimize for video, and then okay, perfect.
Nice. Okay. Looks good. Let's. Okay, perfect. Remove this. So. Yeah, Amazon has its own Zoom, so I actually don't use Zoom that much. Go figure. They call it Chime. Anyway, so yeah, I was a professor. I've been at Amazon for about 3 years now, and I wanted to share a real industry application that I've been working, full-time on for 3 years and developing, just to give a sense of sort of the priorities, the way we think about things, because you all are solving problems that we have, and the more that we can get you working for us, the better. So I'll introduce you first to my team. So Maya Luster is a PhD candidate in industrial engineering at Purdue. Marlena Frowney is a professor in psychology at New Mexico State. Greg Jaggers is a software engineer at Amazon. And Brian Zhang is a PhD candidate in robotics at Oregon State. And here you see us standing in an Amazon sortation center. So when you order a package, it starts in a fulfillment center. A truck carries it to what we call the middle mile, this facility here. And packages come in on one truck, they go out on another truck, and there's a big sort that goes on in the middle. So that's basically the problem that we're working on. We're not trying to replace a single worker. We're really trying to make their jobs and their lives a little bit easier. So let me explain our mission. So associates, when a truck comes in, they will unload the packages, unload them onto this flat cart that you see here. And then the robot is summoned just using a hand scanner. The robot will pick up the flat cart and sort of ingest it inside of itself and carry it. You'll notice how it is moving among people. It's reactive to people. It has a safety system to make sure it doesn't run into people. But beyond that, it tries to be expressive, predictable. So you can see here it's using lights to signal. I'll talk more about that a little bit later. Anyway, the robot gets to its destination, which in this case is the sort area for what we call non-con or non-conveyable packages, which are packages that are too big to go on the conveyor or too heavy or would make a mess, like kitty litter, for example. You'd never want kitty litter to spill on your conveyor belt. So that's our mission. Now, if I were to take the purpose of this workshop literally, it's actually pretty boring, because you've got a bunch of robots and a bunch of people sharing a space, but the interaction is really pretty boring, which is the associate scans a barcode, and then the robot comes and it's completely hands-off from there. It's autonomous. There's supposed to be no human intervention. So that's the task. But there's also a team aspect to this, which is that the robots and the people are all sharing this space. They're working together. They have to navigate past each other. And so really the interesting interaction here is almost incidental. It's the pedestrian navigation among Amazon associates that's occurring while the robot moves from point to point. Now, to give you a sense of what these sort centers can look like, this is an older model of our robot, which was called Catchfly. The new one is called Bluebell. So you can see there's people carrying pallet jacks piled high with packages, shrink wrapped. It's pretty cluttered in there, and it changes constantly. So this is a time-lapse video of 24 hours in the sortation center where we operate. And you can see how at certain times of day, it's almost empty. And then at other times of day, packages get stored and prepared for loading onto the truck. And so the map is changing all the time. And so this is just a part of the challenge, is that our navigation system, mapping, perception, planning, they all need to be able to adapt on the fly at the scale of the facility, but also at the scale of sort of the personal area where the robot is operating in order to do collision avoidance. So Wolfinger tells us that there's this pedestrian bargain, which we all follow when we walk down the street. It says that people must behave like competent pedestrians and that people must trust other people to behave like competent pedestrians. So that's a bargain. The question is, what does competence mean? Well, it's complicated. I'll show you a counterexample. So this is from our old robot. So here's a scene. The camera was quite low on this old robot. And you notice this associate is carrying this pallet jack, probably weighs about 800 pounds or something like that. And I'll play it again. And he's hardly paying any attention to this robot. He's just walking on by, but the robot snags on the edge of the pallet. And you can imagine at that point, our associate was probably not too happy about that. So in this case, I don't think it was the person being, violating competence. I'm pretty sure it was the robot. I wasn't here for this incident, but I would say that in this case, the pedestrian bargain said that as the robot was merging into traffic, it should be yielding the right of way. So simple rule that we naturally would follow when we were in that situation. But the robot was a little too assertive. This is a hard problem because social navigation is automatic. It's largely subconscious, right? It's something that we're talking, we're listening to music, we're usually doing something else while we're navigating, daydreaming, right? Amazon associates are all ages, but they have enormous training in how to navigate, right? How to socially navigate before they start their job in the sortation center. I was curious, so I looked up. The average American adult walks about 2.5 miles per day, which means that by age 30, they've probably walked about 25,000 miles, right? So that's a lot of practice, navigating much of it among other people, avoiding collisions, learning how to predict, anticipate what people are going to do. So I've seen a few talks that were related to pedestrian navigation, social navigation today and at the conference. It's really exciting to see all the new methods that are coming into play. But this is the magnitude of the task, is that we have 30 years of learning potentially that we need to catch up on just for our robot to be competent. Right, and there's no training about how to navigate. It would almost seem silly to tell someone how to walk down a hallway, right? It's something that people innately know. The environment is novel, right? The sortation center, it's crowded with pallets, with packages, all kinds of interesting things, and robots. But associates naturally fit in, they figure it out, and before too long, they're right in their natural element. So what do associates want from a robot, or what do they need? So we did a focus group study to find out. And the associates told us that they want robots to keep a distance of something like 3 to 4.5 meters or 10 to 15 feet, especially when the robot is moving quickly. They want the robot to move at a typical walking pace, the same as humans would do, about 1.5 meters per second. And they want the robots to give priority to people, in particular, people with heavy loads, people with restricted vision, such as if they're pushing a large cart, for example, which Amazon uses a lot of, or limited mobility, which again, if you're pushing or pulling a heavy thing, that really limits your ability to react and maneuver. And actually, these rules of precedence are completely general. If you think about people running on the sidewalk, it's probably the runner's job to avoid collisions because they're more agile. If you see somebody in a wheelchair or in a walker, they're a lot less mobile. Typically, other people are going to take the bulk of the responsibility for avoiding the collision in that case. So again, these are rules that are ingrained in people. Also, people would like our robots to drive predictably. It's very reasonable. Stay out of the way. And this can take a few forms. For example, pulling over to let people pass, because often people are faster than the robot. Or, and this is something I see humans do too. You start to turn down a corridor, realize that there's not enough room to get by because there's somebody with a heavy load, and turn around and go a different way. So on the fly replanning in response to predicted future interactions. And that's tricky because it's contextual based on all of these pallets and everything that's laying around. Also, don't overtake. The robot is big and bulky. The first video I showed you, Bluebell, that's 2 meters long and 1 meter wide. So it's almost as big as a smart car. So it's understandable they wouldn't want to be passed by that. And they would like it to communicate its intent in a simple manner. So what do associates want from developers, from us? They would like us to communicate why the robot is there and what it's doing. And this is something that I often see break down because developers just want to make the robot work, right? They know what it's doing there. They know what it's all about, but the associates don't. And they trust the robot a lot more if they're communicated to directly. They also ask for training on how to interact with the robot. And I think what this really means is, can I trust it to be competent? And if not, how should I respond? Keep a certain distance, for example, or yield the way to the robot. I took the opportunity to cross-train as an Amazon associate. So I took the full training that associates would take before they start the job. And I operated as a stager, which means I was pulling pallets around all day. And I made a number of observations. On the subject of passing side, I often hear people suggest that pedestrian navigation can be solved by keeping right, or left, I suppose, if you're in Japan. But it turns out it's not that simple, at least in the sortation center. My observation was it's about 50-50 whether people will pass on the right or the left. And the reason for that is that it's very contextual. There might be a bigger gap on the right, so people move in that direction. Or you might be turning left, so you'd rather stay on the left side to make your turn easier. Thirdly, if you're following an associate and they pass on the left side, you'd better pass on the left side too, because if you pass on the right, you're going to cause traffic, right? You're going to cause somebody else to have to weave back and forth. So again, it's contextual. You need to be responding to the way that people are behaving in that environment. I also noticed that people do a lot of reasoning about where other associates are going. And you can do that based on, for example, their load. If I'm carrying an empty pallet jack, I'm headed to the staging area to pick up another load. If I'm carrying a full pallet jack, I'm probably headed to the outbound dock. And they know this. And so when they are approaching a turn at right angles, they can actually anticipate and know who should speed up and who should slow down in order to smoothly pass each other without any communication, even hand signals. They also use gaze direction quite a bit. I think when necessary, people will use hand signals or even voice, but it's very rare. I see a lot more just eye contact used expressively at intersections. How does an associate think about the world? Well, a lot of these assumptions are actually just a very standard mental model that are not specific to Amazon associates, but I think it's worth listing them out because robots don't follow them, many of them. People are aware of each other, right? So we're responding to each other's presence. People don't stop for invisible reasons, which if you've ever written a motion planner, you've probably dealt with real world perception, which sometimes will detect speckles that look like obstacles that aren't really there. So all those fun engineering things turn into HRI problems. People don't stop in the middle of a highly trafficked area. So if you had to stop, you'd pull over to the side and try to get out of the way. When the path is clear, typically everyone is going to find a pretty similar plan from point to point, right? It's unlikely, for example, if you've seen the family circus, they draw these very meandering paths. That's not how normal adults would navigate. So there's this predictability aspect just based on what the problem should be. People move parsimoniously. That is, they try to optimize energy. There's research suggesting that in particular, people are minimizing jerk, so the derivative of acceleration. But the result is that you get smooth trajectories. They don't wobble, they don't accelerate and decelerate more than necessary. People yield to higher priority traffic. This requires a definition of what higher priority and lower priority is, which we talked about earlier. People signal intention before making a surprising motion. If you realize you forgot something and you're in a busy hallway, you're probably not just going to spontaneously turn around and go the other way because it would cause a collision. So you might make an exaggerated motion to signal that something unusual is about to happen. People predict each other's motions. And what that means is that you can count on other people predicting your motions too, and use that to your advantage. People expect others to cooperatively avoid collision. And in a way, that's a synopsis of everything that came before, because it requires prediction, it requires awareness, et cetera. So here are a few particular ways that a robot in general would violate the mental model. Firstly, it has bidirectional motion. Unlike a car, it's just as happy driving forwards as backwards. And in times, it has to do that if it's at, for example, in a dead end and there's not enough room to get by. It can turn in place. And again, it'll do that when it needs to. You don't see cars doing that. Also, the robot has a safety system, which is based on a LiDAR safety field, we call it. An area that if it gets penetrated, the robot will halt. Halting is not a very good behavior for HRI because people can't see the laser. They don't understand why it halted. And the problem is that it varies in shape and size as the robot is moving. And so you don't have that feedback to inform people of what's going on. So the planner needs to incorporate the safety field and make sure that it very rarely, if ever, is getting triggered. All right, so now I'm going to talk in more detail about lights and sounds because we did user studies on those this past summer. There's two horizontal light strips. The bottom one is 17 inches above the floor. The top one is about 1.5 meters above the floor. There are rings of 24-bit RGB LEDs. There's about 300 of them on each strip, 60 LEDs per meter. And you can command them at 60 hertz. So you can do full real-time animation if you want to. And you can have a lot of fun with that. For sound, we have a stereo speaker front back. And we implemented a behavior in Pure Data, which is a visual programming language, which does mixing and synthesis. And thanks to Brian this summer, it interfaces with ROS. The program that you see here is the sound behavior that it has while moving. And in particular, this is a melody that does not restart when the robot changes behavior. Some robots get really annoying because if you're playing a WAV file and the behavior flips and then flips back to the previous state, then it starts replaying from the beginning, and that gets really monotonous. The tempo also varies with velocity to keep it more interesting, but also to give you information. So if the robot is coming up behind you, you know how fast it's coming. It also fades to the front or the back according to the direction of motion. And that way it's not disturbing people who don't need to care about its presence. All right, so I'm going to talk a little about the user study design. This was a really hard problem because associates are a unique population. We, of course, have access to Mechanical Turk, but Turkers don't respond in the same way as associates do because they don't have that context of being on the job and knowing everything that goes on. Secondly, they're very busy, so it's hard to survey large numbers of them. And this led us to have to make some decisions that look a lot different than most papers that you'd see at an HRI conference, for example, where you're talking about, p-values and statistical significance. We cannot do any of that realistically in this setting. Instead, we did a qualitative study. We spent about 30 minutes on average with each associate, and we used primarily the think aloud method. And it goes like this. Suppose I'm your best friend calling you on a cell phone. If this is a movie you were watching, how would you describe what's going on? And basically, we're asking people to narrate the robot. It was a 2x2 design. So we had, at any one time, we had 2 conditions in the light or the sound behavior. And then we asked them to repeat it, pushing a cart and also unencumbered, just walking. So we got the sound. So I don't know if you could hear that, but that's our lights and sounds playing at once. So this is the car metaphor. You can see blinkers, headlights, taillights, and when it slows down, there's brake lights too. Another condition that we tried is this one. So this really takes advantage of the animation capability. And so the lights move in proportion to the velocity. They turn green for acceleration, red for deceleration. This one is the same idea, but in reverse. So here it's indicating the direction by moving in the same direction. So visually it looks busier. And pretty universally, people preferred the first of that pair over the second. So we only really studied that pair. In our user studies, people brought up a lot of topics, right? They weren't we were not asking specific questions. And this was a really useful guide because it told us what we needed to work on first, how to prioritize. So we were changing the light condition. So people noticed the lights quite a bit. But the second thing after that was motion. They wanted better quality motion. They wanted more predictable motion. And so that really told us, okay, this is something that we need to prioritize working on, which we've been doing. And they had questions about, how does the safety system work? Before we added sound, they were asking about that too, because it's very quiet otherwise. I guess I'm going to need to speed up a little bit since time is running short. I'll just give you a sampling of the results. So without lights, when the robot was stopped for a moment, some participants expressed confusion. I'm in front of the robot, right? I don't understand. Now it's going backwards, right? And the lights really help to mitigate that. Once you observe it and figure out, but you have to watch it for a few minutes. So the lights maybe weren't that intuitive. This person was watching the car model. We found not everybody understood the car metaphor immediately, that it was supposed to be like a car. It's something that I think either it clicked or it didn't, which surprised us a little bit. We surveyed we asked about both the top and the bottom lights and which one would help. People said they want both for maximum visibility. It turns out the bottom ones reflect off the floor, and that actually is very helpful in a lot of situations for visibility. I'm just going to jump ahead to sound. People noticed when we made improvements and came back, which was really exciting. People seem to like the sound. You heard it a little bit. It was kind of like an organ, maybe. And that gave people that extra situational awareness. And they seemed to think it was pleasant. One of the things that surprised us about sound was the initial pattern that we had planned to use was more of a drone that varied with velocity, but it completely blended in with the background noise. Well, I don't want to say completely, but it didn't stand out enough. And so people didn't like it as well. And this sort of melody was much more effective because it cut through the machinery noise. Yeah. So, okay. So I guess we have about 2 minutes left. So I'm just going to jump to the end. And you've been a wonderful audience. I'd be happy to take questions.
Great talk. It was super nice to see how users and developers can interact, Oh, thank you. How users and developers can interact to make something that's meaningful in the workplace. We've done some user studies as well to test our system, talking with the users. And I don't know if you figured this out, but there was a bit of like some awkward moments where people weren't really believing in the technology. And I was wondering, how did you tackle that? And if you figured this out as well through these studies?
Do you mean believing that it was like not Wizard of Oz?
No, sort of like I don't know if it's going to be actually helping us out as much as you sort of like describe or
I
not.
see. Yeah, actually, one of the quotes I skipped over, the bottom one here, confidence in Amazon, because I worked with smaller robots, the Kiva robots, that there's hundreds of thousands of now deployed. I think I have confidence enough that Amazon will not put things on the floor without making sure that they're safe. So they trusted that they're safe. They also, by and large, trusted that they were useful. Amazon is not a company that's known for doing frivolous things. So I think that in this context, one of our leadership principles is frugality. So I think people really trusted that this was something that was going to be valuable. And they could see how it was valuable to them to save labor, to reduce injury. So yeah, I think it was a pretty positive sentiment.
Nice. Good. Thank you very much.
Thanks.
All right, so there is a very interesting question on Slido, but we'll take it during the panel discussion in the interest of time.
Okay.
So let's thank the speaker again.
Thank you very much.